Hello everyone, and welcome to the 14th episode of Cooking with Unity. I'm your host, Max Moreau, and today we're going to be doing side-scrolling platformer games, like auto-scrolling platformer games. Let's get back onto my screen here. Alright. So, first off, Pushy Pixels, my company, our latest game just launched. It's called Proton Pulse, and it's available on iOS right now. The name is spelled just like this. And just search the App Store for Proton Pulse. Buying the game really helps support the show. So, but obviously no obligation. But just throwing that out there. I've also given links on the chat bar on the right to check it out and check out a video for it. I wanted to actually broadcast the video, but my internet can't handle it, evidently. So let's actually get started here. So, side-scrolling platformers. So what I'm talking about when I say that, auto-scrolling platformer, is a game like Cannibalt or what was the Robot Unicorn Attack from Adult Swim, where you are a character that moves from left to right or right to left automatically, and then you have to jump or otherwise evade obstacles. Jetpack Joyride is another good example of this, but you'll get the idea when we start making it. So what we're going to start with here is let's start with a plane, because that gives us a good starting point. So we're going to create a plane, and we're going to create a directional light, and we're not going to mess with it too much other than that. Just going to move it out of our way so that we don't have to see it. Let's put it up at 30Y or something. And let's make a character. What's going to be our character today? Let's go with Capsule for our character. We've typically done capsules as evil things. Let's do a capsule for a character for a change. So, not that capsules have that much more character or less character, just mixing it up. So we're going to call this our runner. Actually, let's just call him player 1. And let's make our plane considerably larger. Let's see. Yeah, that'll work for right now. Actually, let's make it 100. We're just going to make it very long and thin. So hit play, and we have this, which actually kind of funny how that worked out. I didn't really intend to position him exactly there, but that seems to have worked pretty well. So it's left side of the screen, and yeah, we've got a little piece of ground. So where can we go from here? So objects are going to be basically coming in the right side of the screen, and I'm going to first set this up in a manual way, where we set up some obstacles and we move the character and the camera over, and you attempt to jump the obstacles. That's going to be in the initial setup. And then as we progress on this, I want to actually make it more where the levels themselves are procedurally generated. So you'll have different experience every time, but a consistent one that's fair and allows you to continue the game. So let's start by just moving our character way over to the left, all the way to wherever this thing starts. So we made this thing 100 long, right? So the plane is 100x, which isn't actually exactly 100. When you're dealing with planes, they're a few units wide. I think they're 5 units wide. So it's considerably longer than that. As you can see here, to be on the left side of it, we're basically at 500, which is 5 times 100. So I was right about that. Or I guess they're 10 units because it could be either direction. So I hit play, and you don't see much because the character's way over here. So the first thing we're going to do is we're going to start with simple camera. And the simplest way to have a camera follow the player is to just actually attach the camera to the player. So we're going to do that here. We're going to go ahead and drag the camera into player 1. And then I'm going to set it to position 0, 0, 0. And then we'll bring it back like -9. Oh, I guess we can see the preview here. So -8. And so this is now a child of the player. And so its positions here represent its position relative to the camera, relative to the player. So now if we move the player, like if I just take the player and move him, the camera will actually move along with it. You can see the view frustum of the camera here, and it will move along with the player. And this is a super easy way of setting up camera motion, and because it's super simple, you don't get a lot out of it, but it'll work very well for our initial prototype here. So we have our character, we have our camera, we hit play now, and we have our character centered here. So we don't want the character perfectly centered. We actually want him to be near the left side. I'm going to be doing the standard scrolling right thing to start with. So we can adjust the camera. If we select the camera here again, you can see its position. We can actually adjust it, and these are all, again, relative to the character. So the character will stay in this position on the screen once we have it set up this way. So I'm going to go with 6 on the X here, and that gives us pretty good. And I'm going to go ahead and move the Y position slightly. Not that high. All right, so we have our character. He's on some ground. It's kind of 3D ground. That's fine for right now. Let's make him... How are we going to set this up? Do we want to go character controller style, or do we want to go physics style? Choices. I think I'm going to go physics style because I'm more familiar with it. Character controllers are a good way to go, and but let's just start with just a physical object. So we're going to add a what is it called? A physics rigid body component to him, and we're going to make it so that he can't rotate. So we're going to freeze all the rotation axes. And we probably shouldn't freeze any position stuff. So I'm going to go ahead and move him up a little bit more, so we'll make sure that he has proper physics. So he should drop as soon as we start the game. There you go. He drops and hits the ground, and that's good. All right. So, maybe we should be doing character controller on this because it will make some of our life easier. Let's work with this first, and we can always switch to character controller later. So we have a character. He's just kind of chilling there. And we need him to run to the right. And so first, we need a texture or something. I'm going to just import something from the built-in libraries here. Import package. Let's go with... I think terrain assets have some textures in it, so I'm just going to go with that. And it beeped at me. Import package, terrain assets. Oh, probably because I'm playing. So, waiting for that. I don't know. Actually, let's just get a texture from the internet real quick. Let's see. What do we want today? Let's go with something abstract. Let's go abstract art. And again, if you use any images in your game, make sure that you have get get permission or do your own art. Really, like that's the best thing to take away from this. But that looks kind of fun. Let's go with the full size image, and as soon as that's done, I'm just going to save it to the desktop, and then throw it into Unity. And we're going to put this on our plane, hit play. Alright, so it's all stretched out. Let's make it less stretchy. So we're going to go into our material, and while it's running, it won't save this while it's running, but we'll just adjust this so that it looks kind of like something. So let's try 100. There, that looks pretty good. It's not going to loop very, very well, but at least we have something that has some texture so you can see motion once we start doing it. So I'm going to just make it 100. And so let's start by making our player move right. We're going to create a C# script. And we're just going to call it move right for right now. And open it up. So here we go. Should be zoomed in enough. So here we go. What are we going to do? All we're going to do is every frame we're going to move the character to the right. He has physics, so what I think I'm going to go with is I'm actually going to apply a force to him every frame. So we're going to actually make this fixed update, because when you're doing physics stuff, it's generally safer to use fixed update. Fixed update runs every physics iteration rather than every frame, which is typically it's set to be smaller than every longer time between frames, but it's guaranteed to happen. So with some provisos. Generally, if you're doing anything with physics objects that use rigid bodies, you should be doing it in fixed update. You can sometimes get away with not doing that. So fixed update, what we're going to do here, we're just going to apply a force. So rigidbody dot add force, and we're going to do one that uses force mode. It's just going to be so we want it to go to the right, so that's just we can actually probably just do transform dot actually let's just do vector3 dot right. Do we have that? Alright. That'll probably work for us. And force mode, we're going to do velocity change. And so this should start him moving just with that statement. Let's actually see if it works first. So we hit play. And, oh, we didn't attach the script. So attach the script to our player and hit play. Alright, and he's constantly accelerating and just flies off the edge there. Alright, so that's not exactly what we want, is it? Velocity change. I would have expected that to not continue to add the force. I guess it does it that way. That makes sense, I guess. Impulse, force, acceleration. None of those will. Oh yeah. Actually, let's try changing one more thing here first. We're just going to go back to velocity change. And we're going to multiply this by time dot delta time. I just want to see if it's actually accelerating or if that was just my brain saying it was accelerating. and that wasn't enough force to actually overcome friction. This is probably not the best way to do it. Alright, let's not use forces, let's just actually move him. Why not? We could just use the rigid body for our vertical. So we're going to do it the way we've been doing this before. So transform dot position plus equals vector 3 dot right times time dot delta time. Let's see what this does. It should move slowly to the right. There we go. Alright, he's scrolling slowly to the right. That's good. Alright, so we have our character, he's moving to the right. Let's actually make it so you can adjust the speed that he moves. So we're just going to create a real quick public float speed equals we'll put out f, we'll just start that there, and then we just multiply that in here as well. So times speed times time dot delta time. I like to put the time dot delta time at the end so that I know that I didn't forget it, so it's not hidden somewhere else. But it really doesn't matter. In this case, we could have these in any order, and they're going to do the same stuff. Yes, that's true. I did not just lie to you about that. Order does matter when you're multiplying vectors together and doing operations with multiple vectors, but with scalars and vectors, it doesn't really matter. So now we can go on our player and we can adjust the speed. So let's start playing and then adjust our speed till it feels like we're running a little bit. Alright, cool. So this will work. We'll probably start it at 1. One's too slow. It's a good minimum speed. Yeah, 5 is looking pretty good. Let's do 4 actually. And 3. Alright, so yeah, 3. I like 3. So we're going to go with 3. It's probably too fast, but we'll actually get some gameplay going on here first. So I'm going to zoom in on our gameplay area a little bit. And, so far I couldn't see it. Come on. Actually, as I focus here on our player. You can hit F a couple times to focus on any object, which is quite useful. So we have our player, and we have the camera, and the camera follows the player, which is nice. So here we go. Let's add jumping to the game real quick first before we edit our level. So we're going to make another script called jump. We could have also put this in the same script, but I like having things kind of modularized. Jump. And what this is going to do is we're going to, in our update loop, we're going to check to see if anyone's pressed a button. So if input dot get key down, and we're going to make it space. So key code space is what we want there. Input key code, key down, key code space. Alright, we're just going to rigid body dot add velocity. No, add force, sorry. Add force vector 3 dot up and times add force vector 3 dot up times jump power. We're gonna make that real quick. I'm not putting time dot delta time in on this one because this one's just gonna instantly happen. Public float jump power equals 100.0f. Let's see how this actually goes. So we hit play. Oh, we put the script on the player first, so unhit play. So we grab jump, throw it on player 1, hit play, and when we hit space, we get this very tiny little jump. So, because it's just applying the force once, like a real jump. So let's actually make the, okay, so the default jump power, that was enough to see it, I'll just leave it there, but let's change it in here. Let's change it to 1,000 and see if we get a respectable jump out of it. Wow, that was a heck of a jump. Yeah, okay, 1,000's too big. 100 too small, 1,000 too big. So let's go with 300. Alright, cool. So we can jump now. It's a little floaty, but it's just using the physics thing. Right now there's a bug. We can actually jump as many times as we want. If we hit space and hold it, it doesn't do anything. But if you hit space multiple times, you can just jump and fly into the air. And the reason for this is we're not actually checking to see if we are on the ground. So we need to add a check to let us know that we've touched the ground. So we're going to take this plane. I'm going to first rename it to ground. And we're going to tag it as ground. So we're going to add a tag. Go to tags, add ground. And then we're going to go into ground again, make sure it's actually tagged as ground. And so what we're going to do now is on our jump script, we're going to change it around a little bit. We're going to add a on collision thing. So void on collision. I'm going to go with on collision stay. Collision. So on collision stay, if collision dot collider dot tag equals ground, we are going to need another variable here, private can jump equals false. Private float, no, private bool can jump equals false. So on collision stay, if collision.collider.tag equals ground, equals ground, can jump equals true. And then when we actually jump, we say, so we need to, if input get key down, we can add an or statement. So if we do these two vertical lines, they're usually above the return key on a keyboard. That's the or operator. So we can put another thing that can happen here. So or actually we don't want or, we want and. So and. So if we hit space and we can jump, we jump. And we also need to make sure that when we jump, after we're done with that, we set can jump equals false. So now it shouldn't allow us to jump while we're in the air. We might add double jumping or triple jumping later, but for right now we just wanted to operate simple. Oh, I was able to get 2 out of it. So, jumps. So I can get 2 jumps out of this for some reason. I wonder why that is. Let's look at our script again. So, if can jump equals false, on collision stay. If collision.collider.tag equals ground, can jump equals true. Okay, so what's probably happening is it's probably still colliding at the time that this happens. So I'm going to see if I can just do fixed update here. This is probably not going to be a good idea, but let's see what actually happens. So hit play and tap space real fast just to make sure that this isn't. Nope, we're still getting that double jump thing, so that doesn't fix our problem. To explain what I think is happening here is we're adding a force to it, and then in the next frame it still says on collision stay. Let's actually go with enter. Let's just do on collision enter. It may just clean this up real quick for us. Stays a little safer for stuff like jumps, but this should probably work. So we jump, you can only jump once. Okay, that works. And since we have this 3D ground, I'm actually going to set it so the character's a little bit closer to center. So I'm going to go back to our camera here and adjust the Y to be 0.5. Maybe just straight on. Let's just do 0. So we'll see how that looks. That's good, but I don't like to see the edge of the geometry there, so I'm just going to move this up until we just can't see that. Alright, 0.8. I'm going to go with 0.8. So 0.8. Depending on your monitor setup, you may want to change this so that it doesn't show through. It's just a pet peeve of mine. I don't like things showing through like that. So we have our character. He can jump. And now we need to give him some obstacles. So let's start with just some blocks. Just some very simple stuff. So we're going to create a cube. And what is this guy positioned at, actually? Player 1 is positioned. I want his Y. So his Y doesn't really matter, right? No, that's the ground. Player. Player 1. He drops in, so the Y doesn't matter too much. The position there. We want the Z to be 0. We're going to make Z 0 so that if we put everything in 0, it'll work nicely for us. So our cube Z is going to be 0. And its Y is going to be 1. Does that put it right on top? How about? Okay, so where did we put the ground? Let's adjust the ground a little bit. Let's put the ground at. Let's go with negative 0.5, because that means if we put the cubes on it at 0, they'll just be there. That's for the 1 unit cubes. And we're just going to use those because they're easy to work with right now, but it'll make it so that you don't have to do so much positioning. And so just the X position is really all that matters for these cubes as far as enemies are concerned. But let's actually tag them and make them useful as enemies. So, oops, position 500. So let's first make them red so they pop. Let's create a material, red. We change the color to be red. And we throw it onto our cube. Like red. I don't know. Again, we're not doing this show for art. We're doing this show for explaining how things work and making things operate. We probably will do art segments at some point. My business partner Justin, who works with me on Pushy Pixel stuff, he is good at the art portion of this stuff, and he will probably do some episodes in the future. Just giving the heads up. So we have our cube. We're going to call this obstacle, and we are going to tag it. I'm going to go ahead and tag it as add tag. We're just going to call it obstacle. Alright. So these ones, we're just going to make it slow you down or something. And yeah, that's what we'll do. We'll just make it so it slows you down. I'm debating on setting all this up as one big script for the character, because I don't usually set things up that way, and I kind of want people to understand that you can. I'll think about that in a second. So obstacle, we tag it as obstacle, and I'm just going to see what it does first if we just have this here. I'm just going to put it like 450. Yeah, I don't know how long that'll take to get to. Let's go 490. Hit play. It'll probably just pass right through it. No, oh, it actually stopped us. That's nifty. Wasn't expecting that. So that's good. So we can jump over it. All right, cool. That worked out real quickly. So Cannibalt, which is part of the inspiration of this little game, its obstacles can't kill you; they just slow you down. And when you hit them, they basically fall through the world or fall off the world, and then they don't block you anymore at that point. So let's make it so the enemies have the script for what they do to the player. That way, you don't have to have this huge monolithic script for what each thing does, and each thing can determine what it does. So we're going to create a new C# script called slow down and fall away. So this is going to happen when the player collides with it, and we're just going to create on collision. Sorry, void on collision. Enter. It took me so long to type that. Collider. So this will happen when it impacts anything. If it collides with our player, let's double check the tag for the player. So first of all, player 1, tag him as player. So if collision, where's collision dot collider? Oh, whoops, I did this wrong. Collision. So if collision alright, I'm going to save, and maybe autocomplete will start cooperating with me. Collision dot I've spelled this right? Whatever. Collision dot collider dot tag equals player, then we're going to do stuff. So if collision.collider.tag equals player, I'm not going to need any of these things. Well, we might need them later, but we can always type them in later again. If it equals player, we're going to we're going to get the player's move right script. So we're going to collision.collider get component move right dot speed. What are we going to do? Should we subtract some, or we should multiply it in by a percentage? So times equals what does this equal? We're going to make a variable. It's going to be called public float slow down amount percentage. And we're going to default it to 0.9f. And we're just going to put this in here, and we're going to make sure we have semicolons where we need them. So, so we do that, and then we need to get this thing off the road and make it so that it doesn't bother us anymore. So we can let's actually give these things rigid bodies. So we're going to go to our obstacle here. I guess we'll give it a rigid body in a second. How do we keep it from colliding with the player again? Let's just pop it off the map. Let's just shoot it off in some direction. Let's make it so it doesn't do the private has slowed player equals false. So we're going to put an and has slowed player private bool. All right. Kind of a little topsy-turvy today. Alright, has slowed player equals false, and so not has slowed player. Has slowed player equals true. So this will only happen once now. So what we're going to do is we're going to kick this thing. We're going to add a rigid body dot add force. And we want it to, let's just pop it towards the screen a little bit. So I'm going to go with vector 3 dot back. So that should be towards the screen. And let's actually add a another vector in. So vector 3 back plus let's do one of our random things here. We did random on the last episode. Let's use some random stuff. So plus random on unit sphere. So this will be towards the screen by 1 unit, plus some random vector that makes it no longer necessarily towards the screen. So we really only want it to kick in a vertical direction and not in a downward direction. So let's just make this thing work first. So we're going to do vector 3 back plus vector 3 dot up, and we're going to take all this and multiply in public float kick power kick power. And let's see what this actually does. So we're going to hit play. Oh, got a problem here. Private bool has slowed player equals false. Oh, I didn't put a semicolon there. Alright. Gotta use your semicolon. So we're going to put this slow down and fall away on our obstacle. And we're going to hit play. And we should see the player kick this thing. Oh, missing component. Oh, we don't have a rigid body on it. So, which is what I wanted to add earlier. So, inspector, we want physics, rigid body. And, yeah, let's give that another shot. So it should kind of kick out. Okay, it did, but it did not provide nearly enough power. I'm going to go back to our character. I just noticed a problem with him. So we're going to freeze his Z position, so he's always in the Z plane. He actually kind of started sliding around when he hit the cube there. So let's look at the obstacle. Let's change this kick power to 1000. See if it actually will kick itself off the ground. Bam. All right, cool. So yeah, that worked. So when we do this, it should also make the player slower. So player speed is 3. Okay, now it's 2.7. So that part worked. So now we have these obstacles that can slow you down. I'm actually going to make them yellow because they slow you down. We might make some stuff that kills you, and I like to save red for that. So let's make another material. Create material. Yellow. We make it yellow. Yellow is a good color for slow down. So, just because of all those signs. I'll throw this on our cube. And now let's create a prefab for this. So this is our obstacle prefab. And now we can just place more of these in the level. So we have this set where we like it, right? Yeah. So let's make it so there are. Why can't I click this? Oh, sorry. Click. What the heck? Oh, I'm in move mode. That's the problem. There we go. So we're gonna make a few of these. I'm just gonna hand this over a little bit, and I'm gonna hit duplicate. And we're going to move it. I'm going to duplicate again and move it. And let's see. We're not limited to putting these on the ground. Well, we are right now because of the way they're set up. So let's change our prefab here a little bit. Let's make it so these things do not actually move at first. So we're going to say is kinematic on them. So now when we change that, that should change it for all of them, right? Yes. All right. So actually, let's just use gravity off. That's a better way of doing this. So we'll do use gravity. Whoops. Sorry. We actually want to change this on the. We'll just apply this here. That'll apply it to the prefab and change all the other ones. So now we can actually put things up a little bit. So you can have things that you slide under. So let's just hit play on these 3 little obstacles. See if we can get by them. Oh, I hit it. Might have to make our jump a little bit better. And this is going to be too low, isn't it? Yep. Alright. So let's move this up a little bit. And first let's change our speed slightly. So we're going to make it 4. And let's see, what else are we going to do here? Let's make the jump power a little bit higher. Let's make it 400. And see how this plays a little bit. So we jump over this. Alright. And we jump over this. And we go right underneath this one. I'm going to pop it up. Oh, yeah. Alright. So that seems to work. So we have basically a method for creating levels here by just moving things around. As I said, when we're done with this, we're going to actually make it so that it generates its own levels. But I wanted you guys to see how you could do this in case you wanted to make levels specialized for a game like this. And also because it'll help you understand what we're doing when we actually start automatically generating these things. So I'm just going to be lazy and kind of repeat this pattern. Just going to hit duplicate and drag it over. And so we have kind of a very, very basic thing here going. The way I've set this up so far, we have a ground, which is our plane here. And that's fine if you don't want to have fall into your death. I kind of like fall into your death. So at some point, we're going to be replacing that with something that's not just a big, long strip, but rather sections and platforms and stuff. So let's make an evil little spike obstacle real quick. So this one will actually kill the player. And so let's do that. Let's create are you serious? There's no cone or... Huh. And none of these are parametric in any way. Huh. I really thought that we had a little cone or something we could work with. Okay, well, I'm going to cheat. I'm going to create a cube. We're going to rotate it in a special way. Where's our rotation stuff? So we're going to go 45. Then we're going to rotate along this axis, so we get some form of spike out of this. And then we're just going to sink it into the ground and make it red. So put this at 0, 0. Actually, let's go negative 0.5. So now we have a little spiky do thing. Really cheap way of doing it, I guess. So what these are going to do is they're going to kill the player when the player hits it. So we're going to create a script. I know we've done this one before, so I'm redoing it again. Gib on collide. Since we've done this before, I should probably just grab the way that we did it before. It's good practice. So we're going to attach this to the player, and if the player hits a spike, they're just going to die. So I'm going to set this in kind of generic way. Public string, we're going to make an array, collide tags, and then we're going to do public public game object Gibbs. And this is going to be another array. Going to go with public game object, public int amount, so that we can do duplicates of just one gib very easily. And what else? So we've got our strings, our game objects, and our amount. And then let's do public float explosion force and public float explosion radius. Let's actually spell things right. Explosion force, explosion radius. So let's set these to something that's useful. So first of all, this one will be 1. This one will be we'll do 100F again. So let's do 1,000. Let's do 100. Change it. And explosion radius, we're just going to make it pretty small. I'm just going to make it 1.0f to start. This is just to get things to go into a radius. So, I'm kind of glad we're doing this one again since we've done the random episode, and so this will give you some idea on how this stuff works. So, we're going to do on collision again. We don't need this stuff, so void on collision enter. So what we're going to do is we're going to instantiate some gibs. So for int I equals 0, I is less than amount I plus plus. And then inside here, so this will make it so whatever we set for amount, it'll repeat the gibs that we set in game object in gibs that many times. So now do a for each over our gibs. So each game object gib in gibs. So what we're doing is game object reference equals instantiate gib transform dot position plus random dot inside unit sphere times explosion radius, and then the last parameter is the rotation. So Waternian dot identity as game object. Alright, so what this does is it instantiates a gib at our position plus some random number inside of our explosion radius and a quaternion identity, and we get a reference to it that we can do stuff with. And so our reference dot rigidbody dot add explosion force position is transform dot position, and our explosion radius, I guess we'll just use explosion radius again. Alright, so this should generate some gibs, and then once we're done with everything, we destroy game object. So, if all goes well, this will give us a nice little explosion when the player hits something, and we're going to make it so that there is a tag that he can hit that will do this. So let's first tag our cube. So then we're going to call spike, actually. Spike. And we're going to call it add tag spike. We're going to actually set our spike to have a tag. Oops, where's our spike? So this is going to be a spike. And then we're going to, on player 1, throw gib on collide in here. And because I'm kind of strapped for time, we're just going to use objects that we already have for our collisions here. So we're going to actually create a prefab for spike. This is going to be kind of awkward. We're just going to have it spawn spikes and obstacles for right now. We'll actually tweak this later, but I want to get this done, and it's late tonight. So gib on collide, we want our collide tag. I'm going to add one here. And we're going to do spike. So it should work on spikes. Oh, I didn't actually do that part, did I? Yeah, let's actually make this only happen for spikes. So if collision dot collider dot tag equals we're gonna need a loop on this. So for each tag, string tag in collide tags. This way, if we have multiple tags, we can do that. If collision dot collider dot tag equals tag, actually I'm going to call it collide tag. That way, in case tag is probably a special thing, so we don't want that. So if it matches, then we do this stuff. So spike, and we're just going to make our gibs obstacles and spikes. Whoops. So we're going to hit this. Oh. That could have been bad. Luckily, it didn't want that at all. So I'm going to hit the little lock thing so that I can click these things and drag them in. So we're going to put spike and obstacle in here, and we're going to make the amount 10, so it'll be 10 of each. And I'm going to go ahead and preemptively do explosion force 1000 because I think I'm going to need that. So hit play, and let's see if this worked. So we jump, I'm going to run into this one, it slows me down. This time we're going to hit a spike, and whoa. Oh yeah, the spike doesn't have, oh god. No, don't render any more frames. Oh, my computer's dead. Come on. Oh man, and I didn't save either. Alright, gonna force quit this. Alright, you probably didn't hear anything for a few seconds because I just made a classic mistake and Unity crashed. So I'm going to get back into Unity real quick, and we're going to find out that I didn't save at all during this whole session. So I'm going to do a 2-minute rebuild and call it a night. So dang, wow, I really screwed the pooch on this one. So what had happened was there was a script error, which made it so that it was continuing to create things well until forever. And so it created a lot of things and crashed Unity for me. And I didn't save it all because I am an idiot. And you should not do like I do and not save anything. So we're going to start this over real quick. We're going to create our plane. It's going to be at 0, 0, negative 0.5, 100. We throw abstract art on it. We do the tiling of 100. We call this ground. We put it as, oh, all my tags are gone too. Ground, obstacle, spike. We make sure our obstacle is tagged as such. Come on. Oh, great. These don't exist in any real way, do they? Great. Alright. Probably because they have the tags that don't work. Wow. I can't believe how badly I did this. Alright, so create directional light. Throw it somewhere in the sky. We create our capsule. We name it player. We make it a player. We put them at -500. We add a Rigidbody. We freeze his rotation, freeze Z position, add the move right script to him, add the jump script to him, add the gib. Let's leave that one off for right now. We create a cube. We call this obstacle. We make it yellow. Oh, it didn't save any of this stuff. Alright. Yellow needs to be yellow, right? We throw this on the obstacle. We make red actually red. Gonna create a cube, call it spike, throw red on it. On the obstacle we throw slow down and fall away. We add a rigid body, we turn off gravity. What else are we doing here? Let's put this at -500. 0, 0. We attach our camera to the player. Set our camera position to 0, 0, 0. -8 is what we did. We set the X positions a little bit more to the left. Let's go with 3 this time. Let's move the player slightly more to the right. 490. Let's actually zoom in on the player. Come on, give me the player. Let's put this thing over here. Where's our spike? Let's see here, -500, so we can see it. 0, 0. We put this at -0.5. We rotate the thing. So we do a rotate like undo rotate. Do like 45 degrees. 5. We change it to global. We rotate it up about right. We tag it as a spike. We hit save right now. Save as test level. We make these into prefabs. Obstacle will tag as an obstacle, even though I don't think we actually use that. We use a slow down and fall away. We put gib on collide for our player. We make the spikes have a physics component as well, just because we're using them as gibs. Freeze. This is not going to work, is it? We're not going to use it as a gib. We're just going to remove this entirely. And move this thing over here. Just make sure that they both work. jump we put at, 400? And we put speed at, 3, 4? Hit play. Oh, we didn't kick the box hard enough, so the obstacle needs to take power 1000. And so now on the player, we're going to put Gibbon Collide. We're going to add the yellow box, the obstacle to our Gibbon Collide script. We add, what is it called? Spike to our list of things to give with. We set the amount to 10. The explosion force we're just going to do 1000, and explosion radius 1 is fine. And we hit play. And we'll hit this, it falls away, hit this, our player explodes. Oh! That's right. That kills our camera too. Alright, well, let's start there on the next episode. As you can see, it's easy to do things once you know how. Yeah, alright. Well, thank you for joining me for this episode. Thanks for bearing with me as I rebuilt the whole project, because I do not save enough, learn from my mistakes. If you want to contact me, go ahead and email me at pushypixels@pushypixels.com. Again, I'm your host, Max Moreau, and thanks for watching. And if you have a few extra bucks, buy Proton Pulse for iPhone or iPad and all the i stuff, and soon to be on for Android. I'll let you guys know when that's up. You guys have a wonderful evening. Good night.